Hello, welcome to a new video. In this video, we're going to talk about the architecture of Deepseek v4. Now, to do this, we're going to go through the Hugging Face reference implementation. This one's really nice because it's very readable. It's not very optimized, but it's very readable, and we can kind of build intuition on what's going on. So, as we've talked about in past lectures, these transformer networks are actually really conceptually simple. We take our inputs, we get their embeddings, and then we run through our transformer layers, and then we calculate the logits. And in today's video, we're gonna focus on this part. So let's get started with this. So what is self.embed? Self.embed is defined here. It's this parallel embeddings class. So if we look up parallel embedding, we can see that what is it doing? It's setting the vocab size and the embedding dimension. And then you get to some interesting parts here. So what is world size? So world size is basically how many GPUs are participating in this model. And part vocab size is basically the size of your vocabulary divided by how many GPUs are participating. And conceptually, what we're doing here is we're sharding the vocabulary across the GPUs. And what this is doing is basically calculating the indexes based on the rank. So if you're GPU 0, the indexes are like 0 to k. 0 to k. And then if you're GPU 1, the index is starts at k and ends at k times 2, etc., etc. And then so we initialize basically a shard of the overall vocabulary for our particular rank. And then down here, what we're doing is we're calculating these masks and then doing this index math to make it such that morally we're doing something like this, where, imagine if our vocabulary is size 4 and we have an input that looks like this, then rank 0 is in charge of calculating for all tokens in the input sequence which ones are 0, and then rank 1 is in charge of for all inputs in the input sequence which one's 1, etc. Obviously this is contrived. In practice, rank 0 would own a range, maybe 0 to 25,000 or something like that. And so after doing this, we call this dist.allReduce. And what is allReduce? AllReduce is a collective. And what is a collective? A collective is when the GPUs communicate to each other, typically by sending tensors to each other. And in this case, allReduce by default is a summation. So what happens when you sum these tensors together? You get a tensor that looks like this. And this is morally what would have happened had you had one ginormous embedding matrix on a single GPU and you just indexed in. So that's why after you call the forward of this, you actually get the correct embeddings. You get precisely what you would have expected. Okay. So now let's talk about shapes. So this H, what is the dimensionality of H? So in the innermost level, we have 4096, right? The innermost level is just going to be our embedding size. And then the second dimension is going to be the sequence dimension. So for example, if you had 4 words in your sequence, then S equals 4. And then the third dimension typically is what is the batch size. So imagine you had 3 separate ChatGPT threads, then your batch size would be 3. It looks like this. Now, Deepseek v4 has this interesting thing called a hyperconnections. And what hyperconnections is morally doing is duplicating your batch size, sequence length, and embedding 4 times. This HC mul is set to 4 in Deepseek v4. And the reason why you do this is because, like, modeling reasons, where you want to have 4 at the start and then they get transformed in different ways as it flows through the network. So in practice, like, morally, you can think about it as like hyperconnection by batch size, by sequence dimension, by hidden dimension. But in practice, for perf reasons, it actually gets represented as this. So when we call this h.unsqueeze.repeat, in practice, it ends up creating something that looks like this, where it's batch by sequence by 4 by 496. Yeah, and so at this point, h is that shape. And in the next lecture, we're going to see how h gets transformed over and over and over again through these transformer layers. So yeah, see you next one.